Welcome, welcome, welcome. Good morning, good afternoon, good evening, wherever you may be. Thank you so much for joining me today to discuss this topic of drones in the terrestrial LiDAR workflow. Those of you that have joined, maybe you've worked with just drones, or maybe you worked with just terrestrial LiDAR. What I aim to show you today is you can actually combine these data sets and some of the examples and benefits of doing that. I've worked with drones and LiDAR for about 7 years. And actually, it wasn't until I started ATG a little more than a year ago that I knew you could do this. So this topic has been always been impressive to me that this is a possibility. And so I wanted to share that with you guys today. A little about me. My name is David McQuillan. I'm a senior reality capture specialist. And for those of you who may not know, what a reality capture specialist is basically it's my job to take whatever's in the real world and create a 3D digital representation of that on your computer. A little bit about my background. I have about 10 years in surveying mapping with a master's in GIS. When I was in the program, there was one class that was specifically on 3D mapping. Those of you may be familiar with GIS, it's really tailored more towards 2D mapping. But you know, I love that 3D mapping class, and I latched on, and I haven't let go yet. Another thing about me is I just got back from my bachelor party. Went to Nashville, saw a lot of great music, had a lot of fun. That was a really cool city. I had never been there before, so very cool. So here at ATG, we make a lot of content. We, every week we'll have a webinar, a full length webinar like I'm doing here today. Also, we do like short tech tip videos. But I've got a blog being released on the website here pretty soon. That's going to be on using drones to create digital terrain models. So please, if you miss the sound of my voice, you can find a couple more videos of me on our YouTube page or also our LinkedIn. We share a lot of stuff. We're very active on LinkedIn and on YouTube. So please take a look at that. I want to shout out to Bimbox. So Bimbox is our hardware computer partner. If you guys have used drone data before or LiDAR data before, you know it can be pretty heavy stuff, both in data size as well as the visualization aspect of it. So these machines are great because they were built specifically for these use cases. It's what I'm using today. It's what all of our technical specialists use at ATG here. Highly recommend it if you are using this type of data to get one of these bin boxes and increase your productivity, increase your speed. Nothing's worse than having to sit around all day waiting for things to cook. A shout out to our hardware and software partners. As I go through these hardware and software partners, I'm also sort of describing the workflow that I'll be going through as well. So identifying, who these partners are, but also what they do, especially in terms of this workflow. So first here on our left, we have Esri Site Scan. Esri, as you may know, is the largest GIS software platform out there. They have a drone side now, and that's called Site Scan. And what Site Scan is, it's basically a two-parter. It's got an iPad app for flight planning, which I'll be showing you today. And then it also has a cloud-based platform as well that you would access, through your desktop computer or something. And that's for data processing, data manipulation, data exports, things like that. But, so with the drones and the mission planning, I'll show you that with Esri Site Scan app. Next up on the list is Leica Geosystems. They're going to be they're the hardware manufacturer for the LiDAR scanners that we use. Whether that's the BLK 360 or the RTC 360 or the new BLK to go, etc. The P series, they make the LiDAR scanners. Then we have Autodesk. As you guys may know, ATG USA is a platinum partner for Autodesk. And some of the software that I'll be showing you today from Autodesk is one, Recap Pro, which I'll get in a little more detail here in a second, but also Infraworks and Revit. So the next one is Recap Pro. That's good. That's a software. Again, you can use that. You can use Recap in the field, data collecting with your Leica Geosystems BLK 360 there. Also doing field registering, but also it's a software that we're going to be using most importantly to merge the two data sets. Something that's really great about Recap Pro on your desktop is it's pretty data agnostic. It doesn't really care if you're using a Faro system or a Leica system or whatever scanner. You know, it takes a wide variety of point cloud data types. So, also just want to mention at ATG, you know, we use all these things as services. We also sell all these things. We will support them, we'll train on them, everything like that. So if anything piques your interest, make sure to give us a shout. So I just want to bring it back in here for a second. So today's mission is to show you that drones aren't just a standalone reality capture tool, and neither are scanners for that matter. You know, we want to show you that you can combine them. So the agenda / learning objectives today is we're going to zoom out a little bit. You know, what are drones? What are they used for? How do they work? Same with terrestrial LiDAR scanning. You know, what are we using? How do they work? That sort of thing. Next, we're going to do a live demo. I'm going to show you the SiteScan app, how to do a couple of drone flights, drone flight plannings, to better to make sure you have better success at merging those data sets with the terrestrial LiDAR. And then I'll show you how to do it in Recap, and then show you a couple different use cases or really just different software that you can put those data outputs into and do some other manipulations in there and stuff too. So, all right, so drone hardware, you know, we've got the obvious things: propellers, stands, batteries, things like that. It's really what I want to show you here is one, that the drone itself has a GPS unit on it, and two, its payload. Payload being mostly a camera. I've heard people say things like, you know, drone scanning and things like that. Yes, LiDAR can be put on drones. It's not too common. It used to be because the tech wasn't really there. I think the tech's getting pretty close these days, but really it's the cost, I think, is prohibitive right now. So what I'm trying to say is that drones still mostly use photogrammetry. So it has a camera on it. That's its payload. It takes a lot of overlapping photos marked with a GPS coordinate. And then basically through the science of photogrammetry and whatever sort of software that you're using, it's going to give you your data outputs. Those data outputs could be your orthomosaic photo, your point cloud, you know, things like that. Then we have here to the left is the controller. You know, I'm sure we've all seen people flying drones with the handheld controller there. That's all well and good. You can create your data outputs from that as well. But really, the goal today is to show you the autonomous mission planning. So, you know, we'll be using the satellite imagery with, you know, some polygons and basically creating our flight lines, and once that's created, we can upload that to the drone, and then the drone will basically operate and navigate based off of GPS and not through manual control. So the way I like to divide up drone mission planning or even drone data sets is horizontal and vertical. So I'm just going to sort of briefly explain the benefit, or, you know, what happens on either one here. So horizontal, what we're looking at here is a digital surface model. This digital surface model, you know, that we may be looking at an orthomosaic photo, which is basically taking all those individual photos, putting them together, and now we have one large one. Or we take all those individual photos, put them together, and we have our point cloud. Either way, we're looking at digital surface model here. And something pretty interesting that I wanted to highlight is what we're looking at here is we're taking what's called a current surface model, and it looks like we're comparing it to a design. And so we're left with a heat map of cut and fill. So, you know, if I was a project manager on this construction site here, I would know, you know, basically we could calculate how many tons or cubic yards of earth we need to move in order to meet our design, and whether that's cut or fill. And then of course, just overlaying the parcel information on it as well is very useful. And we have over here to our right is the vertical style. So this is really what I mean more when we're combining with uh, with our terrestrial LiDAR. You know, with the terrestrial LiDAR, we'll most likely be operating that inside the building, you know, maybe outside on the base level of this building. And then we're gonna use this vertical mission planning to combine those two data sets. I also want to point out here is that, you know, like I said, we're taking pictures with the drone. So when you're doing your vertical mission planning and you're creating this 3D object, this point cloud, don't forget you also always have those photos gone in the background. So if you ever want to use it for like inspection type purposes as well, it's a great use case for that too. Now we have our terrestrial LiDAR. So terrestrial LiDAR, you know, that can be either a tripod, and most of the time we're talking about tripod-based terrestrial LiDAR. It could also be mobile-based too. Like I mentioned earlier, Leica has the BLK2Go, which is a handheld mobile scanner now. You may have seen the backpack units. I mean, there's even truck-mounted or car-mounted units as well. But you know, most of the time we're talking about tripod-mounted LiDAR units. Next thing I want to mention is that LiDAR is it's an acronym for light detection and ranging. So maybe you heard of sonar, right? Kind of works the same way. It's an active laser, active piece of light that's gonna emit and then hit an object or a surface, and then basically based on its speed and angle will assign you know, an XYZ position, and that being done millions and millions of time is what creates our point cloud, and then that, you know, that point cloud is our 3D object there. So these laser scanners, they're often paired with cameras. So this camera one, I mean, it's nice to have a you know, the photo orbs or the cameras that the photos that be able to easier to understand the space that we're in, right? But also importantly, they're used to colorize the points. So another thing is that most of them are, or at least modernly, are self-leveled with some sort of IMU, but some of them are also bubble leveled. And then just real quick, discussing the different sort of styles we're looking at here. So one, we have the P series, the one in the middle there is the RTC 360, and the third one is the BLK 360. And I just wanted to point out just a couple differences here in case you're curious about scanners. You know, as we can see from the size, we're probably looking at power differences, and that power, you know, it means basically what's your point density and what's your range. So as we go smaller in size, we could assume that we're dealing with less point density and less range as well. But it doesn't mean that it's worse. You know, it's kind of like finding your Goldilocks zone. You know, what do you need for your job? For example, the smaller one here, the BLK 360, we've got guys from our team right now doing a plenum plenum job space, plenum space job. Sorry. Um, so you know that scanner there is about the size of a coffee can. So really good for popping some tiles. You know, following the track of the mechanical or electrical, you know, going on up above in that plenum space there. So really it's about just finding what scanner works best for you or what job you're trying to do with it. So now I'm gonna stop sharing my screen from my desktop, and now I'm gonna start sharing it on my tablet. There's a little bit of delay here, so bear with me. All right. Excuse me. Take a drink of water. So I wanted to show you a couple different mission planning types. First one's the most basic. It's area survey. So let's hop into that. We'll try to be aware of the delay here. So starting off here, we can give it a name, give a location. We don't have to, so I'm going to go ahead and click next. Next thing, I'm just going to go ahead and zoom in our satellite imagery here for a little bit. And I'm going to go ahead and move basically our flight area. And then we can go ahead and move the vertices here. We can even add vertices by selecting in the middle of the lines here. So basically through this polygon, we've assigned our flight area. Now, if you could, I'd like you to pay attention. As I go ahead and manipulate things here, keep an eye on the bottom part. See the 5-minute estimated 0.5 inch per pixel, 3.58 acres, 41 images, 1 battery, things like that. Basically, it's going to be giving us direct feedback here. So first of all, I'm going to go ahead and move this. So it's at 200 foot elevation. But go ahead and change that. Now something that you notice is that our inch per pixel, or our ground sampling distance, now has increased to 0.8 rather. And then now this hatch angle, you can go ahead and move this. Basically the angle of our flight lines there. Not too big of a deal with this one. You can leave it how it is. If you have sort of an odd shaped polygon that you're working with, maybe you can change that to make it a little bit more efficient. Other than that, maybe you have a real strong tailwind or something like that, and it might make it more flight efficient to make a crosswind instead of a tailwind. So next we have here is overlap. So I'm going to go ahead. So first of all, we're here on the top left. It's called overlap, but I would say more accurately call that front lap. So that's basically one photo in front of the other. So let's go ahead and bump that up to 75. This will adjust basically the speed of the aircraft, because most of the time the camera is controlled by the shutter speed. So, if the shutter speed or the stabilization of the camera is slower, then you're going to want to fly slower as well. So keep that in mind. It does impact the amount of mission time, but usually not by much. So I like to bump that up a little bit more. Then we have side lap. So this is right to left, right? So now we just saw that we have more flight lines now. We've gone up to from 4 minutes to 5 minutes. Acre's still the same, but we have more photos. And then maybe, if this is a larger area, we'd be working with 2 batteries instead of 1. So pretty basic, but gives you a nice overview of what we, some mission parameters, how they impact the overall time and complexity. All right, next I'm going to go into vertical. So this is really where we're talking more about, we're with the area we went over horizontal, right? As I mentioned before, now we're going into vertical. So again, I can give it a name and location. I'm going to go ahead and skip that. Zoom in here. So basically what we're looking at is this blue line is what we would line up to the side of the building. Maybe we can do that. So what this vertical is, this is really just getting one side of a building, right? So think more like a dam. We're only really flying one side of a dam, right? Because the other side probably has water on it. But all right. So the blue line is basically the wall or the actual structure. and the green line is where the drone is going to fly, and that'll be more clear when I go into 3D mode. But for now, I'm going to leave it like that. All right, so we have our slope. We can go fixed or variable. I'm going to go ahead and save it as fixed. The slope degree or angle is 90 degrees, so it's straight up and down. Now we're kind of defining the space of the object or the dimension of the object. So the bottom elevation, that's going to be 0. 0 is registered as wherever your aircraft is turned on at. So I'd suggest basically activating your aircraft at the bottom of the structure, and that's going to make it 0. And then the top elevation, well, I guess we could call it 100 feet tall. But basically, that's the height of your structure. So if the structure was 100 feet, but it's probably more like 70 or 50, right? So anyways, then we have our minimum flight height. I'd like to say, you could drop this down to 10 feet or even 20 feet, but honestly, most aircraft these days, they have warning sensors on them now, and they actually won't allow you to fly that low. So I think I found is the lowest you can really go here is 25. Other than that, you'll probably have to fly manually. And then the maximum flight height, well, if our object's only 100 feet tall, we wouldn't be flying at 300, right? So maybe we just go ahead and do that 110. And then our departure slash return height, that's basically when it takes off, it's going to just go straight up to a certain height and then go to its flight line. So if the tallest object around is, 100 feet tall, then we don't really need 300, right? So maybe we just do this 125. And then the offset, that's the distance away from this blue line. So I think, usually I like more like 50 or 75 or something like that. But really it's about what's safe, what's capable. You don't want the drone to be knocking into anything. So I'm gonna go ahead and get a better angle here. So this top one, this top overlap here, that's basically how many flight lines are on top of each other. And then the side lap is much more like the front lap we talked about before, but this time it's, it's side to side as it moves horizontally, how many more pictures it's going to take. Hopefully that all makes sense to you guys. If there's any questions here. No questions yet. So as you can see, it's there's other ways to do this, right? I've done things where you fly manually. Maybe you turn on take a photo every 3 seconds or something like that. But this takes that work out of it and takes the guesswork out of it, and it really just makes it more efficient, and if you're worried about how many batteries you have, might as well fly more efficiently. All right, now the last one. So instead of just doing one wall, we're kind of building the structure here. So this is the length and width, right? Then I can draw accurately. Yeah. Well, let's pretend that's a tower or a grain silo or a water tank, something like that. Again, we have our offset. Maybe do something more like 75 or 50. So now we're closer to closer to that object. And this is interesting here. Basically, we get to build the object that we're flying around. So the height of the structure is at 100 feet. The minimum flight height, well, if our height of the structure is 100 feet, we probably want to go lower than that, right? So of course, safety is the most important thing. So our lowest that we're flying is 35 feet. Our highest may be 120. So basically we're trying to fly as low as we can and then right up to the top of that structure. And then again, just getting over the height of that building there. So with all these, we could have gone ahead and saved the flight plan. I think obviously when you get out there, things might be a little bit different, and you should always be checking that before you take off. But generally speaking, let's say you're trying to quote a mission. Somebody's asking you to fly for them, and you want to know basically how many batteries it might take, or how much time it might take, or basically trying to do any sort of pre-planning ahead of time. That I found this to be an excellent tool, and would definitely recommend it. All right. So I really put this slide in here because I just want to make sure that people are aware that there is a difference between using a drone for reality capture and a difference between using LiDAR scanners. LiDAR scanners, first of all, what is the word accuracy and what does that mean to both drones and LiDAR scanners? Most of the time when we're talking about accuracy for drones, we're talking more like positional real world accuracy, especially when we're talking about terrain data and things like that. And then when we're talking about accuracy for LiDAR scanners, we're talking usually more about point density. So basically how realistic is this point cloud actually representing the object in the real world? So I just kind of want to point out that LiDAR scanners are more accurate. Oh, got a chat message here. Yeah, so got a question here. So do you have a list of drones compatible with this Esri site scan? It's all the DJI drones. So any DJI manufactured drones, and also there's another brand out there called Unique, YUNEEC, I think. All those are also compatible. So just kind of throw out a quick comparison here of the both very efficient time in the field wise. Processing time that may vary, right? Depending on how big your mission is. But just want to point out that LiDAR scanners will pretty much always be more accurate, just because it's an active sensor instead of a passive sensor. It's using lasers instead of photos. But I think really when we combine them, the lack of accuracy on the drones doesn't really matter, because what's happening I guess it really depends on the use case, but the assumption is that you're going to model this anyways, right? So if there is like a slight variation in the surface of the roof or something like that, we're most likely not, we're just going to draw that roof anyways, right? So in the modeling software. All right, so that concludes the PowerPoint. So time for the big reveal. In Recap Pro, I'm going to show you how to merge the two data sets. So on our right, we have drone, right? Fairly obvious, nice overhead look. We're missing some stuff on the side here, but that's okay. We got what we need, right? So now the trick is, you can combine the two data sets, but you need to do it in one scan. So basically what you need to do is figure out where you have the most amount of overlap between one scan and your drone point cloud. So here we have sort of like essentially a map of where all our scans were with our terrestrial LiDAR scanner. And I can identify that over here we have nice, good vertical coverage. So I'm going to go ahead and pop over. Hopefully this doesn't take too long. I probably should have done that ahead of time. All right, done. I like that one better. Basically, this other one will get two sides of the building here. All right, so we're looking at the same the same objects here, right? We got the tanks, the front of this building, the side of this building, these wood pieces here, and essentially what we're going to do is a manual registration inside of Recap Pro. We've got what I'd recommend here is doing all your scanning registration and then adding your drone point cloud. And your drone point cloud, that can be in an RCS format if you're lucky enough to have that, but we're probably going to have it in LAS format, right? I mean, that's a really generic format. So that's totally fine too in Recap Pro. Just throw your LAS in here with all the other RCS files and you're still good to go. Alrighty, so I'm gonna go ahead and get started here. The strategy is I like to do 3 different planes. So I'm gonna go ahead and click here, click here. And so really the idea is you're matching left, right? All right, now I'm gonna go ahead and click here and I'm gonna go ahead and match that on this side. You're trying to get it as close as possible. Doesn't have to be perfect. Didn't quite like that one. Let's try that again. There we go. All right, so that's really what you're looking for is that green circle. If I press merge scan here, it would take a little while. So I'm just gonna go ahead and close this out and show you a finished one, hopefully. So basically that's it. You're copying what you did on the left with what you're doing on the right. You're trying to get 3 variations of planes. Again, I'd suggest doing all your laser scanning registration first and then adding your point cloud and then saving it. And there's my dogs barking, if you heard that. Sorry about that. All right, so here we go. Oh, just wanted to show you there. Got our data organized by location here, and then we have our drone one separate. And we can just go ahead and turn those off and turn those on based on how we need it. But there you go. That's how you merge it. You do it in Recap Pro. All right. Move on from that one. For those of you that are Revit users out there, I want to show you that you can also do the same thing. When we save this, we can save it as a unified RCP. Still have that drone data in there. And go ahead in my visibility graphics. Drop this down. I'm going to turn off my drone, my exterior extended. Bam. And I could have turned off those other things as well. But the point is that we're still, even with this large amount of data, we're still able to import it. And it might be really nice to be able to not only get, the inside of buildings or whatever, or inside of, in Revit, but also the whole exterior, whether that's the roof or, maybe you're building a site plan or something, you want to show some contours, maybe you could build off of this, but so just want to show you that it is a possibility, you can do it. And a tool I find really interesting is Infraworks. I just want to show you here, just turn it off and turn on a couple things with the power the software has. Then turn off the point cloud. So first of all, what we're looking at is data set, just with on the Hawaiian Islands here, we've got plenty of area around it. We've got roads, contour map, all sorts of things like that. Looks like we've got an orthomosaic going on in the background. And then we go ahead and turn on the drone point cloud. So we can add, basically what I'm trying to show here is that you can add several complex, really heavy, beefy data sets inside the software, and it takes it with ease. So let's go ahead and go one further. So we flew this with the drone. We also did some LiDAR scans. And bam. And then what we're able to make was this amazing model based off that information. So we have here at ATG, we have a lot of different teams. One of them is the modeling team, architecture team, augmentation team, etc. Just throw that back together, see how they combine like that. Really amazing stuff. Also want to show that you can also share that information using BIM 360. If anybody, they don't have to have the software in order to see this, you can send them a link through BIM 360 and they can be able to view all this just web-based as well. Well, all right, guys, if you don't, that's it. Y'all have a good rest of the day, good weekend, all that stuff. Stay safe.